The order of operations. PEMDAS. Please excuse my dear Aunt Sally. These are things that you have been hearing about in math for years and years now. But why is it that we continue to bring up the order of operations every single year? Why is it that we talk about it? Well, the order of operations is known as the universal language of math. Okay? It is universally understood that we work math problems in the same way. Okay, well, why do we need that? Why is that important? Okay, well, let's think about some things in our culture that we all understand. It keeps us all on the same page. For example, I've got a picture here of two people showing their wedding rings. We understand that if someone has a ring on their left hand, on their ring finger, we understand that that's a wedding ring, and we understand what that means, right? It communicates the same thing to everybody. That person is married. They're in a committed relationship to someone else. We understand that when we see that symbol. Driving a car. We understand that when we drive a car, it is expected that we're going to drive on the right-hand side of the road. If I'm the driver in the car, I know that it is my job to drive on the right-hand side of the road. It's just expected. It's understood. It's important, right, that we all follow that rule, because if I drive on the right-hand side of the road and someone else is driving on the right-hand side of the road coming the opposite direction, that's a problem, right? We're going to have an accident. It's understood what side of the road we're supposed to drive on. Stoplights. All right, that's important. Those are important symbols, and we all need to be on the same level of understanding with those. We all understand that if it's red, we're supposed to stop, right? It can't be, well, some people stop when it's red, but some people, when it's green, they stop. We all have to operate under the same understanding. Red means stop, yellow means slow down, green means go. It's important that we all have that understanding. Well, in math, it's very similar. We need that common universal understanding. We need to all understand that we're going to do things in the very same way. Otherwise, we could get an awful lot of answers to problems. We could get all kind of answers, and everybody's answer would be right. And we can't communicate that way. We can't all have our own way to do it. So we have this order of operations. It's this universal language of math, so that we all understand the same thing. Symbols communicate the very same thing to everyone. So let's review those order of operations. We always start with parentheses, okay? And when we think about parentheses, we need to broaden our understanding. We work things in parentheses first, but that would also include if we see something inside a bracket, that would come first. If we see something inside of braces, that comes first. If we see something inside of absolute value symbols, that comes first. So we got to broaden our horizon. It's not just parentheses. It's any kind of grouping symbol gets worked first, okay? After we've checked a problem and we've worked the things in our grouping symbols first, then we look for exponents, okay? And so if we see a number with an exponent, we know that would be second in priority. Third, we look at our problem for multiplication and division. And when we look at the problem, we look moving from left to right. So, for example, if I saw 10 divided by 5 times 3, as I look across that problem from left to right, division comes first. I would divide first. I would do 10 divided by 5 is 2, and then come to the multiplication. 2 times 3 is 6. It's important with multiplication and division that we work from left to right. We're accustomed to remembering that little acronym. Please excuse my dear Aunt Sally. My dear, multiplication first, division second. And sometimes we get that ingrained in our heads that it has to be that way. Multiplication first, division second. But in fact, it's not that. It's working multiplication and division from left to right. Our last step is we check for addition and subtraction, and that's the same idea too. We look from left to right. So we want to say, oh, it means addition first, subtraction second, but not necessarily. If I have a problem like 12 minus 2 plus 3, the subtraction as I'm working left to right, subtraction comes first. So I do 12 minus 2 is 10, 10 plus 3, is 13. It's important to consider left to right. So let's do a couple examples. Okay, number 1, we do not have parentheses. We do not have exponents. Multiplication and division. As I go across left to right, I see division. So I'm going to do 6 divided by 2 is 3. Now my problem is 14 plus 3. I have one operation left, so I solve that and I get 17. Number 2, I don't have parentheses. I don't have exponents. I'll look across left to right for multiplication and division. I do have multiplication. It says 7 times 2, so that's 14. So now my new problem reads 20 minus 14 plus 1. I have addition and subtraction. I work left to right. 20 minus 14 is 6. 6 plus 1 is 7. Number 3, I don't have parentheses. I don't have exponents. I do have multiplication, so I work left to right. 5 times 7 is 35. 2 times 13 is 26. I now am down to one operation. 35 minus 26 is 9. Okay, number 4. Take a look at number 4. It's written in an interesting format. It looks like a fraction, okay? But it's important that we remember when we have a fraction bar just simply means division. This fraction bar right here means division. So this problem is 45 plus 19 divided by 2 times 8. Anytime you have a division problem written in fraction form, you work the numerator first, denominator second, and then do the division. Okay, so we want to add those steps into our notes. We work the numerator, then we solve in the denominator, and then our last and final step is to do the division. Okay, so let's do that. Let's work the numerator first. The numerator is 45 plus 19. That's 64. Now we go to the denominator. 2 times 8 is 16. Now we go to the division. We solve it by dividing. 64 divided by 16 is 4. Okay? Number 5. We have parentheses, so we begin there. 11 minus 1 is 10. Once I solve the whole problem in parentheses, there's no operations left. I can drop the parentheses if I want. So now I have 3 times 10 divided by 5. Okay, there's no exponents. There is multiplication and division, so we work left to right. 3 times 10 is 30. Now we have 30 divided by 5. That's our final operation. We get an answer of 6.